Hi students, in this video I'm going to talk a little bit about the period of scientific achievement that we see in the 16th and 17th centuries. And this is very much a part of the history and the theme that we're following of the rise of Western influence throughout the rest of the world. The rise in the technological advantage that Western countries have held over the rest of the world, we can pretty accurately date to this time. This is the time when it really manifests itself. What's interesting is that it has its roots in the medieval period. Medieval Christianity is distinct from medieval Islam in the Middle East, is distinct from Confucianism in China in seeing any kind of learning and learning about the world as being an act of devotion, or can be an act of devotion and worship. And this openness to all types of learning had laid the foundation for the scientific successes of the West that we see during this period. And these include advances in medicine, greater understanding of blood flow and anatomy, greater advances in mathematics, the development of calculus, and most famously, greater advances in science, in a greater understanding of the solar system, the beginnings of the development of the heliocentric model. And I'm going to talk about that in a little more detail in the rest of the video, but it's just important to remember that oftentimes this is presented as sort of like the counterweight to the medieval period. So you have the medieval period, people only believe in religion, and then you have the early modern period where people reject religion for science. And the reality is much more complex than that. The reality is the medieval practice of religion lays the foundations for scientific achievement in the period that we're studying in this class. And that many, actually, I think all the scientists of this period are in some way shaped by religion, are religiously minded. So it's not a kind of either or thing, but the two are much more what's the phrase I'm looking for? The two are much more intertwined than generally we tend to think. And so over the course of the 16th century and into the 17th century, we see the rise of this heliocentric model. And the reason that we focus on the heliocentric model is that it's not arguing something that hasn't been argued before. This is another mistake that a lot of people make in studying this period. There's a mindset out there that says people had never considered the idea that the Earth would revolve around the sun before. But that's not true. We can find that in ancient Greek writings, in medieval writings. It was a theory that was proposed. Now, people of the time mostly concentrated on the theory that the sun revolved around the earth. That was the most popular theory. But the theory that the earth revolved around the sun, that was still present. That was still presented as an alternative theory. Copernicus is the astronomer who promotes the heliocentric theory in a new way, however, during this period. And what he's doing that's new is that he's using mathematics to predict the places where the planets and the stars are going to appear during the year in order to support his argument. So the reason that the reason that the geocentric theory had been more popular up until this point was because it was the one that most reflected what people experienced. So people think this is entirely dogmatic. It's not dogmatic. It's based on what people could experience at the time. To their perceptions, the sun was revolving around the earth rather than the earth revolving around the sun. So, two things to keep in mind. People had considered this theory before. The reason that most people rejected it was based on evidence rather than based on religion. What Copernicus is doing is trying to argue that the Earth rotates around the sun or orbits the sun using mathematical calculations. What he is successful in doing is arguing that you can use mathematics and astronomy to argue this position. his argument itself is flawed for reasons that you can look up. And the same is true of Galileo. Galileo's argument also does not prove that the Earth rotates around the sun. Galileo acted as though it did, but the reality is that it did not. What Galileo does do, however, is develop the telescope. And with greater observational abilities, later astronomers are able to make this case and make it more convincingly than Galileo did. These astronomers are Kepler, who proposes elliptical orbits of the planets. So instead of the planets just rotating around the sun and always staying the same distance away from the sun, Kepler argues that the gravity of the sun's pull, will diminish as a planet moves away from the Earth, and so the orbit will slow down. Once he proposes this model, the movement of the planets and the stars and the sun corresponds to the model in a way that it did not do with Copernicus and Galileo. And then the final important support for this heliocentric theory is the laws of motion and the law of gravity that's developed by Isaac Newton. And so you can see how these different astronomers contribute to this really radical reshaping of typical cultural opinion of the position of the Earth relative to the sun. Copernicus is the one with the idea. Galileo is the one who develops the telescope, who observes the phases of Venus, which suggests that Venus is orbiting something, and observes the moons of Jupiter, and so shows that smaller objects rotate around a larger one. And then Kepler is the one who proposes the model that fits the evidence, and then Newton is the one that provides the reasoning behind the evidence. But we tend to just focus on astronomy. This is just one of a number of impressive scientific achievements that are taking place during this period. And we'll talk more about some of the social implications of this in the next video.